Hello children, how are you? Yeah, I'm back again with different type of chemistry. In the last chemistry class, we went with different types of chemical reactions and we have discussed about chemical reactions like chemical combination, chemical decomposition, chemical displacement as well as double displacement. And I told you and I promised you that there are another type of important reactions, namely redox reactions, which I am going to explain them separately. Yes, today again I made a PPT to make it very clear. Now the question is, what are these new type of reactions and where do we come across these type of reactions? Every day in our daily life we come across with these redox reactions. First of all, what are redox reactions? Redox reactions are the reactions where there are two phenomena that takes place simultaneously, namely reduction as well as oxidation. So we call such type of reactions where reduction and oxidation takes place immediately or simultaneously as redox reactions. So in detail, I made a small PPT with an activity which gives you the definitions of all the important terms, right? So here let's see the PPT. Once again I tell you, the chemical reaction in which oxidation as well as reduction takes place simultaneously is called a redox reaction. So here oxidation, first of all, the first phenomenon, oxidation. What is oxidation? The term itself, oxidation means addition of oxygen or highly electronegative element like oxygen, or removal of hydrogen or highly electropositive element. And the third definition for oxidation is loss of electrons. We call it as LEO, Leo. Leo in the sense oxidation. Oxidation has three definitions. You can see on the screen: addition of oxygen or highly electronegative element like oxygen or chlorine or any other electronegative element. Or next, a removal of hydrogen or highly electropositive element like hydrogen. And the third definition is loss of electrons. And coming to the next one, that is reduction, vice versa. This reduction is quite opposite to oxidation. That is, if you go with the definition of oxygen, a removal of oxygen or highly electronegative element, addition of hydrogen or highly electropositive element. And coming to electron concept definition, gain of electrons is considered as reduction. GER, LEO is oxidation, GER is reduction. I know that you are getting scared of all these. Don't worry at all. Here I am telling you, you may be thinking, what is oxidation, what is reduction? No, don't get scared. There is no confusion at all. Once let us watch a simple activity which I made for you.
Oxidation and reduction. Redox reaction. A. Formation of copper oxide from copper. Requirement: china dish, copper powder, burner, tripod stand and wire pickles. Activity: heat china dish, some copper powder. Observe what will happen. We can observe the surface of copper powder becoming coated with black copper oxide. Because oxygen is added from air to copper and copper oxide is formed, 2Cu plus O2 gives rise to 2CO. If hydrogen gas is passed over this heated material of Eluru, the black coating on the surface turns brown due to reverse reaction and copper is obtained. CuO plus H2 gives rise to Cu plus H2O. If substance gains oxygen during a reaction, is called oxidized. If substance loses oxygen during a reaction, is called reduced. In this reaction, copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. One reactant gets oxidized while the other gets reduced during reaction. It's called redox reaction.
So children, I hope everyone understood with this activity. This activity clears you that. See here, you can see here the copper metal is reddish brown in color, and this copper metal, when it is heated, it is undergoing oxidation. Copper Cu reacts with oxygen to form CuO. Copper is reddish brown in color, but this copper, after burning or after reacting with oxygen, it adds oxygen and forms a black colored copper oxide. Of course, here the color is not given. This copper oxide is black in color. This copper oxide, like I say, once again I repeat, the combustion, or let me say the oxidation of copper into copper oxide is done here. And in the second case, you can see there is a gas element, like here you can see an inlet of gas. There is a chamber. They have taken this China dish and they introduce into this discharge tube, and this China dish contains copper oxide, CuO, black copper oxide, and into this black copper oxide, if hydrogen gas is passed, then again CuO reacts with H2 gas and undergoes reduction. From that CuO, oxygen is removed or the oxygen is lost. So such type of reaction is called reduction. This is a simple activity to understand the phenomenon redox. Once again, I am telling you, in the first case, copper is turned to copper oxide. In the second case, copper oxide is turned back again into copper. So I hope everyone understood. So after observing that activity, there are many questions. So let us see the questions. Why the surface of copper powder turns black? Yes, copper. Once again, I am giving the answer for that question. Copper is brown in color. This brown colored copper, when it reacts with oxygen, it adds oxygen, it undergoes oxidation, and it turns to black color copper oxide. Cupric oxide, CuO. Cu is in +2 state. Then the second question. When hydrogen is passed, why black color turns back into brown? Yes, this is a very good question. So the same copper oxide, black color copper oxide, when it is reacting with hydrogen, addition of hydrogen, and this CuO loses oxygen and undergoes reduction. So the copper is brought back. That copper oxide is turned to copper and copper is brown again. Now, what type of reaction is this? You can say in the first case, you can see there is an oxidation done. In the second case, there is a reduction done. So, reduction and oxidation both are done simultaneously. We call such type of reactions as redox reactions. Right, children? Okay, now you can also check out the chemical equations. You have to balance every chemical equation. You can see Cu, copper is solid. Definitely here you have to write the color of copper also. Copper is brown. And this reacts with oxygen, that is gas. Where is that oxygen? Oxygen is present in air. Copper reacts with oxygen. And then you will be getting black color cupric oxide or copper oxide, copper 2 oxide, CuO, which is again solid, and it is black in color. Remember, the color of copper is brown, the color of copper oxide is black. So this copper to copper oxide, what type of reaction is this? This is definitely oxidation reaction. Now, you can see the overall representation of redox. You can see how the CuO is converted to copper and H2 is converted to H2O. This is the way how a redox reaction is represented. Look at the board here, you can see this copper oxide, this particular copper oxide which is having oxygen with it, which is ready to supply that oxygen, is called oxidizing agent. And the substance which is taking oxygen is considered as a reducing agent. To make it clear, I want a simple trick to remember. I am giving you a trick which helps you in remembering. The substance, please everyone keenly listen. The substance which undergoes reduction is called as an oxidizing agent, and the substance which undergoes oxidation is called a reducing agent. Once again I repeat, the substance which is undergoing reduction is called oxidizing agent, just quite opposite. And the substance which is undergoing oxidation is called a reducing agent. So this is what we call it as a redox reaction, right? Now, what is the inference? Once again, these are the answers for the questions which are put for you. That is, the color of copper is, it is turned to black color due to the formation of copper oxide. And again, copper oxide, when it is put in discharge tube containing hydrogen gas, it gets back its brown color. That is, copper is formed because reduction takes place. Now, so what is the objective? Here you are learning that when a substance is undergoing oxidation, immediately another substance is undergoing reduction. Such type of reactions are called redox reactions. Both reduction as well as oxidation takes place simultaneously. Right. So, and once again here I have given a clear definitions for oxidizing agents and reducing agent. Once again I tell you, the substance which is undergoing reduction is called oxidizing agent, and the substance which is undergoing oxidation is called reducing agent. So here I gave some examples also, like copper oxide, zinc oxide are considered as oxidizing agents because they are supplying oxygens. And the elements like copper and zinc are considered as reducing agents because they are accepting oxygen. Now these are the examples of redox reactions in our daily life. You can see all the time your parents will be warning you, like when you cut an apple, you have to eat it immediately. You can't keep that apple like that, because inside apple there is an element, namely barium. This barium, it undergoes oxidation. You can see the color also. The color turns brown in color. This is nothing but, again here, oxidation is done. Next, you can see this one, that is photosynthesis. This picture tells you about photosynthesis. Photosynthesis, that is preparation of starch with the help of carbon dioxide, water, in the presence of sunlight by chlorophyll, is also a redox reaction. And you can see the third picture. What is that, dear? It is nothing but rusting. What is this? Rusting of iron is very good example of redox reaction. Iron is a metal which undergoes oxidation in the presence of moisture. That all you will be learning in the higher classes. Then you can see this one, that is crackers. You know that crackers consists of certain elements like magnesium. This magnesium metal, it reacts with oxygen to form magnesium oxide, giving certain dazzling white sparkling light. So that is also an oxidation reaction. Next, the next and very easy one is, here you can see flame. What is that flame? That is nothing but burner flame. And here we are using LPG gas, that is liquid petroleum gas, or methane gas. That methane gas, it is undergoing combustion reaction, and here the flame is obtained. So these are the general examples of redox reactions. Okay, children. So I hope everyone understood the simple phenomenon redox, and I want everyone to practice. There is a small activity in the first lesson. So I want everyone to go to that activity, read the activity, write down the definitions, and also draw the diagram. Okay? Okay. Stay tuned. I'll be back again.